Hi guys, welcome to the another video of Excel tutorial. In this video, we are going to discuss how we can classify the inventory. There are 6 ways to do a classification. What are these classification? How they are different? How we can model them in the Excel? And what their purpose is. This is we are going to discuss in this Excel tutorial. We have a dedicated tab for each of the classification like ABC, XYZ, VED, FSN, HML and SDE analysis. So let's start with the brief intro of each of the inventory classification. So first is the ABC classification. We all know this is a value based classification in which we classify the inventory which is a high value, low value and a medium value. Then there is a XYZ classification which is more on the demand variability. Then there is a VED classification which is based on the operational criticality of any item. Then there is a fast moving, slow moving or non moving item which is sales specific inventory classification. Then we have HML classification which mainly talk about the unit price. And then there is a procurement related classification of inventory which is SDE classification. So let's start how you can create a model in the Excel and you can do this analysis by your own. So the first and foremost thing is what's the input data required in order to do the inventory classification. So this is the basic input data which I have created for this sample calculation. So first of all, you need to have a SKU, then what's the description, then you have the what's the annual uses, then what's the unit cost, then this is the annual value. So the reason why which this column is blue because it is calculated one. So we just did the multiplication of annual uses and unit cost and figure out this number. Then there is a mean demand. Then there is a standard deviation of demand. Why these data are required? These are important in terms of doing XYZ analysis. Then there is a coefficient of variance of demand. So again, this is calculated one. Then there is a lead time in terms of days. Then what is the availability percentage? So how you are going to get this data? If you're getting this upfront, which is good. If you are not able to get it, then you can use the OTIF percentage like on time in full. If you are able to get that data for a particular item at a particular location, then you can use that data here in terms of availability. Then there's a last movement. So the date when this particular item was having a transaction in your system, what's the latest date? So you are going to put it. You can easily get this data in any transaction data system, or what you can do, you can have the dump of the data and do the aggregation like the latest one, correct, or the date which is at last. So this is how you can get this data. And this notes is just for the VED analysis, the manual way I am just using this column, but there is another way in which you actually calculate mathematically that how you can assign a particular item as a vital, essential or desirable. So yeah, so basically this is your basic data required in order to do any inventory classification. Let's move to the ABC classification. So this is the sheet for ABC classification. So here we have some text around it that what is ABC classification. We know that it's a value base. We classify A for top 80% of the value, and next B is a 15%, and another 5% which are remaining 5% are C category. Okay, so here these are the steps how you can perform this on the Excel. But yeah, I think it's not very tough. It's super easy. You just need to write down all of your SKUs and then you need to write down their values. Here the one critical point is that you need to do the sort from largest to the smallest on the value, so that you can have your cumulative percentage of your value rightly calculated. So we have this sort and then we have calculated this cumulative percentage. It's a very simple formula, and then you can use this this formula for top 80% are A. So if you see that all of these items are taking 80% of the value, and then these are taking around next 15%, and then these are taking the remaining 5%. So yeah, so this is how you can classify the ABC classification. The only critical point is you need to sort it out before applying any of the formulas. Now moving to the XYZ classification. So this is again a different classification. Usually people get confused with the ABC and XYZ and say that these are the similar, but they are not. So ABC was the value based, but XYZ analysis is the based on demand variability. And we can check that how consistent or erratic demand for the particular item. So what does X mean? X means it is a very stable demand, very low variation and high predictability. It means you can live with the lower safety stock because you know that what demand is going to be there. Then there is class Y, in which you have moderate variation. It means some fluctuation is there and you need to have moderate safety stock. But in case of Z, these are the items which are highly erratic demand. You know when it is going to come and in how much quantity is going to come. Correct? So that is why it is unpredictable demand and it needs safety stock if you want to avoid the stock out. So for that, as I was telling earlier, that you need to create another data point, which is coefficient of variation or CV. So what the coefficient of variance is? It is a statistical measure for relative variability. So what's the formula of it? The formula is quite simple. You need to divide the standard deviation with the mean of that demand. These two data we already have in our input data sheet. Okay. Then what you need to do, you need to assign the XYZ classification on the basis of value of CV. So if CV is less than 10%, it means the demand is highly stable. You need to assign X. If CV is between 10 to 25%, it is moderately variable. You need to assign Y. And if CV is greater than 25%, it means it is highly variable. You need to assign Z and you need to pay much attention in terms of stock availability. So how you can model it in the Excel? It's very easy. You need to write down all of your SKUs. Then the CV, you can get it from the input data and a simple formula in order to assign value to the X, Y, and Z by this case. Now moving to the another one, which is VED classification. So the VED classification, VED stands for vital, essential, and desirable. And this is a method of inventory classification used primarily in maintenance, spare parts, and healthcare inventory to prioritize items based on their criticality to operation or production. So what's the purpose of VED? So the main goal is it to identify which items are most critical to operations so that stock out can be avoided for those items. And unlike ABC analysis, which focuses on cost, VED focuses on operational importance, that how critical a part is to running your processes. So V is the vital. It means item without which operation stop and you have no substitute available. So these are vital for your factory to run. And how you want to follow the policy for these kind of item, you need to maintain high safety stock and ensure continuous availability. You cannot have or you cannot afford stock out on these kind of items. Then there is essential. These essential are the items which are important but not critical. Operation can continue temporarily without them. So they are not a deal breaker or they cannot stop my production line. Although they are required, but they cannot stop my production line. So you need to maintain moderate safety stock. You can have a bit of leniency in terms of safety stock because you know that it is not going to stop your production lines. Then there are desirable items. These items are useful but non-critical and they are used occasionally to have easy substitutes. Okay, and we need to maintain minimum stock. So why safety stock is being critical in this discussion? So if you are going to have a high safety stock, you need to carry inventory more. And how long you are going to carry inventory, you are going to stock up your working capital. And then there is a lost opportunity cost as well, because that money could have been used in some better productive work which can give you more yield than what you are getting right now. Okay, so that is why having an optimal safety stock is very much necessary, and that is why people usually do this inventory classification to come up on the right policy, that which policy you should be having in order to get right number of safety stock. Anyway, moving ahead. So in this VED input, because I am just taking it from the notes column of the input data, so I am assigning it. But the problem is this is not scalable, correct? Here, let's say if you have multiple items, correct? So you cannot provide these values by the gut feeling or your instinct. there should be some mathematically or the data supported decision in order to assign these kind of value like vital, essential, and desirable. So for that we have another table. I just want to show you that how you can do this. So there's something called criticality score. So the criticality score quantify how important each item is to your operation based on multiple dimensions such as impact on production. So does a stock out stop production or not? You need to rate 1 to 5. Then there is a lead time. How long does it take to procure or replenish? Then the availability. It is easily available or rare. And then there is a cost or substitutability. Can you replace it easily? Or then there is a safety or compliance impact. Is it safety critical or this item is a regulated one? So you also need to do a scoring around it. Then around these 5 topics, you are going to assign a particular weight that, let's say, this feature is more important to you in order to define a criticality of any item. Correct? So you will define a particular score rate, and then after having the weightage and whatever number you have given on these features for a particular item, you are going to calculate a final score. That is your criticality score. And as per that criticality score, you are going to assign something as a vital, essential, or desirable as per the ranges. These ranges you can use as per your requirement, but these are something which I have used to demo to you. So coming here, so here we have this first feature like impact on production, which is 2. So if it is 5, it means it has high impact on production, and if it is 1, it means it has low impact on production. Then we have lead time in days. Availability, again, it is something if you can put any score to it. If not, then OTIF is also, or on time availability is something you can check and you can use it as a proxy here. Then you have this safety or regulatory impact. Again, 5 is higher, 1 is lower. And then substitutability score, if you can easily substitute this item or not. 1 is lower and 5 is higher. And now you need to normalize this data for the 100 scale, because we are assigning from 0 to 100. So now for normalizing the production, what you are going to do, because here the impact on production was on a scale 1 to 5, correct? So in order to make it on a scale on 100, you need to multiply it by 20. Okay, so I'm just doing the same way. You need to normalize your lead time, because there are lead time which are more than 100. So I am normalizing this data to be it under the range of 100. Then you have availability, which is already on a scale on 100. Then you will be having the safety and substitutability score, which you can again normalize. Then you are going to calculate your weighted score, and here you can provide weightage as per your need, but here I am providing the weightage like 35% for the impact on production, 20% for the lead time, 20% for the availability, and likewise. Okay, and then you can provide the classification as per the range of the score, which is that, let's say, this item is vital as per my criticality score, this is desirable, this is essential. So this is quite powerful way in order to identify the criticality of your item, and as per you are able to identify the criticality, you are going to assign the inventory policy for them. Great. So now moving on to the next one, which is FSN classification. So we know that what is FSN classification. It is fast moving, slow moving, and non-moving. So it classifies inventory based on their rate of issues, movement frequency, or consumption velocity over a definite period. So the thing is, the rate of issue, it means how frequently you are sending it or delivering it to the internal customer or external, whatever it is. So let's say here we are saying that the category is fast moving. It means it's a high issue or consumption frequency. The behavior is like it issued frequently and it has low average inventory because it is always in demand. So you are not able to replenish, or as soon as you are going to replenish it, you have order to serve. Correct. So we have to keep a check on this, and we have to reorder regularly. The another category is slow moving, in which we have the moderate issue frequency, moderate movement, and we have to monitor closely that, okay, do I need to reorder it or not? It can be some seasonal order, and it can be something like which is not in high demand, but some ancillary product which is being used in terms of repair and all. Now move on third, which is non-moving. So in the non-moving, we have very low or zero movement, not issued for a long. You need to define what the long is, and then the candidate, it is the candidate for obsolescence or write-off or disposal inventory. So first of all, you need to check that when there was a last transaction for this particular item, and you are going to calculate it by this particular formula, and then after getting that day, then you can have a proper classification. Let if something has not moved, for more than 90 days, it is non-moving. Something hasn't moved more than 30 days, but I think past 90 days it has some movement, it means it is slow moving. But you have something which is moving in last 30 days, every month, okay, it is moving, then you can categorize it fast moving. As per your application, you can have this number as a different, but yeah, these are the general numbers in terms of CPG clients. So how to do this? It's very easy. Again, you need to write down all of SKUs, then you need to do this formula in order to how to calculate, correct, that what the lead time is, and then you need to assign your FSN classes like slow moving, non moving or fast moving items. And it's very easy and it's very effective way in order to check that what are the items which I should be focusing, which are giving me money, and you know they are getting sell rapidly. So I can focus on those items and classify them high attention item to get the revenue or cash in regularly. Now move to another one, which is HML classification. So as you know that ABC classification was the value base, XYZ classification was the demand variability, but HML classification is based on the unit price or the unit cost, sorry. So HML stands for high value, medium value and the low value. High value items are expensive units, and they require tight control because too much money is involved. Then there are medium value units which have moderate cost and normal control. Then there is a low value items which are inexpensive and simple management is good enough for them. And we are saying that unlike ABC classification, which is based on consumption value, HML use the unit price alone. And what's the purpose of HML? So HML helps you to identify costly item requiring approval before issues and optimize insurance and storage condition for high value items. That's correct. And then set up appropriate stock level, audit frequency and the authorization limits. Anyway, so how to do this? Again, it's a very simple because we usually have this data which is unit cost data, correct? Either you get it on the basis of as ERP dump. If not, you can calculate it that how much you are able to consume this unit and how much money you have spend on it. You will be able to calculate it, and it's very simple formula. You are just providing in the basis of the percentile values, correct? So let's say what I'm doing here, I'm saying that okay, top 10 percentile are high and then below 50 percentile are low, and you can just use this formula and you can create this particular sheet. And here you are saying that if I okay, so let me just do a filter or the sorting so that we can see that how it is working. Yeah, so here you can see that top 10 percentile of the unit cost item are high, and then uh, remaining 50% are medium, and then below 50 percentile are low. Okay, so yeah, so this is a powerful one in which you can identify and classify your inventory on the basis of unit cost, and you can check that okay, which are my high unit cost item, do I need to insure them, or what are the how I can take care of them so that they should not be obsolete or they should not get damaged. Okay, so now we are moving to our final one, which is SDE classification. And in the SDE classification, it's a procurement based inventory classification. So SDE stand for scare, difficulty and easy, and it is one of the classic inventory classification model used in supply chain management to evaluate procurement difficulty or sourcing complexity of any item, which models like ABC or XYZ focus on value or demand variability, but SDE focus on availability and lead time. So that is how easily an item can be produced from supplier and can be used. So what's the objective of doing SDE analysis? It is to categorize item based on ease of procurement so that purchasing strategies can be aligned accordingly. So S item, which are the scarce item, they need strategic sourcing and long-term contracts. D item are difficult, which need supplier collaboration and dual sourcing. You want some sort of multiple supplier. If one supplier is denying the delivery, then they are easy item. You know that there are multiple supplier available. They can give you the delivery whenever you're going to ask them. So it is very easy. It is a cost based procurement. Then what is the logic we are going to use? So in order to calculate or classify the SDE inventory classification, you need to take two data point into the consideration. The one is the lead time, and another one is availability. Again, availability is something which we can get from the on-time delivery or OTIF, and lead time we know that what it is. So in terms of lead time, you can classify as per your data point and your business and your industry. That if, let's say, if something is lead time is greater than 30 days and availability is less than 70%, it means it is hard to source and there might be very limited supplier. So I should classify it to as a S. And what the strategy I am going to take here, I should be developing long-term contracts, and multiple sourcing should be the way to build resilience around this kind of products. Then if you have lead time between 15 to 30, it means you can get it faster than the earlier one, and they have also higher availability, like 70 to 90%. I think it is moderately difficult, and you need to build strong supplier relationships in this kind of product. Then you will be having the third category, which is you can get that item within 15 days, okay, and it is always available in the market around 90%. So it is very easy to source. And classification we talk about at E, and it means you can do the spot buying as well. But the spot buying, you just call, I want this, and you're getting it, and automate the procurement as well. Okay, it can automatically select that, okay, they have 5 suppliers, and in order to just getting all of a fair share of the orders, and it can do the automation as well. How to do this? There is another very easy formula. We just need to use this formula in Excel, and we can easily classify each of our inventory, like it is difficult, it is easy, or it is scarce, in order to get it procured. So that's it for today. Hope you like this video. And if you want some other topic to be covered, just let us know which topic you want. You can get this Excel in the description with the nominal price. Keep supporting us. Do like, share and subscribe. And thanks for watching.